Got the crowd here.
Change role to panelist. There you go. So you should be a real.
Join as a panel.
And do you share your camera and video and
Okay.
mic, or else it won't show up on the recording.
Okay.
And try to talk into the mic so we can hear your
Audio,
voice in the video.
video. Oh, unable to start video because the host has stopped it.
True.
You have to be on the call the whole time.
Yeah. Are you gonna be a co-host now? Try it again.
Yeah, now I'm done. Cool.
I'm hanging back if you need something.
Oh, switch to.
Owl. Does it make on the
No, I only have my iPhone camera and the computer.
Be guiding her to you.
Okay, sounds good. Just a few more minutes.
This was plugged into that.
So, but this is plugged into the,
This is USB. You have a USB.
oh no.
Yeah.
Do you?
I do. have
I usually have, but I didn't think I would need that.
it. Bill, do you have a USB to?
A USB to USB-C adapter.
Or if I do have, I think just USB. You need the.
USB.
I don't think this goes in that direction. I think this is USB-C.
No, this works.
Does that work?
Yeah, I think so.
Give it a try.
Can you take your?
Yeah, the double out, yeah.
Two, there's one for this.
Okay.
Oh, there's another one. That's the challenge. Okay.
Oh yeah, it worked.
Forget that though. Yeah.
Okay. Yeah, let's do this. Okay, I'm sorry for the delay. I'm gonna try to make it quick so we can have a little bit of Q&A in the end. But also I'm gonna be here all day, so we can chat outside as well. So today I'm going to be talking about managing EKS clusters using EKS blueprints and infrastructure as code. Before I start, let me introduce myself. So my name is Julia. I'm a global technologist at Veeam. I'm also an AWS container hero, and this just happened last week, so I'm really excited about it. I was just a community builder, but I got nominated as a hero, and it's an honor to be that. I'm a CNCF ambassador, Google Women Tech Maker ambassador, Girl Code ambassador. I'm a YouTuber, and I joke I was born in the cloud. So I don't have a computer science degree. I wasn't technical. A few years ago, I taught myself how to code and started in the cloud directly. So that's why I build a lot on AWS, build and break. And when I'm not building and breaking things on AWS, I like to cook, train Brazilian Jiu-Jitsu, and I love to travel. So now, besides myself, I want to introduce you Amanda. This is her picture generated by AI. We were just talking about AI. And obviously, she's a fictional person, but let's pretend she's the head of DevOps at a company called Tech Solution. And her company decided to move their workloads to AWS and mostly on Kubernetes, so using Amazon EKS. And they want to deploy quickly all better included EKS clusters on AWS. And her goal is to optimize her team's productivity, also the developer, all the team's productivity, and streamline their operations. Now, this is what her environment looks at first. So the data plane architecture, she has two managed node groups, one using an M5 instance type, and the second one an M6G instance type, allowing for flexibility in running different type of applications. And then each managed node group is spanning across two availability zones. and with multiple instances scaling up and down. But that's not enough. Amanda is also facing some challenges because setting up Kubernetes is just a platform. Setting just the clusters is not enough. You need to install tools on top of that. You need to establish observability, reliability, persistency, security, cost efficiency, all these things. So it becomes more powerful. And these add-ons, again, they can encompass a wide range of features and capabilities that enhance the core platform of Kubernetes. And if you haven't heard, there is the CNCF, the Cloud Native Computing Foundation, which hosts Kubernetes, and they have more than 150 open source projects that you can build and install on top of Kubernetes to enhance its functionality. So this is the CNCF landscape. There are a ton of projects, but the problem is there isn't one straightforward way to install all these tools together. There isn't a guide, a step-by-step guide telling you, oh, if you want these tools, that's how you have to install them, put them together. But thinking about these add-ons that I mentioned, now this is the solution that Amanda arrived at. She decided. So she has her EKS cluster that I mentioned, and she wants to deploy several different tools. So for instance, the Nginx proxy for a specific managed node group to act as an ingress controller, external DNS to manage the DNS records, OPA, so the Open Policy Agent for policy enforcement, Argo CD for continuous delivery, also Prometheus and Grafana for monitoring and observability. And also she decided to install Vimkasten for Kubernetes for backup, disaster recovery, and application mobility for her Kubernetes workloads. But now again, the question is, how can she group all these components together? How can she maintain, upgrade, and optimize these add-ons? It's not easy, it's not straightforward. Now, on top of this, her cluster is what we call a multi-tenant cluster. So she has different teams that will need to access her cluster. So at first, she has developers that will need to assume specific roles, each requiring appropriate permissions. She also has platform engineers and DevOps administrators that need different set of roles to manage the cluster as well. And maybe different users that will need to access the cluster sporadically also need access. So she needs to manage the access control and permissions for the cluster for all these different teams. And if that wasn't enough, complicated enough, on top of that, she wants to follow best practices. So she's going to have different environments and different clusters for her workloads. So she has a development environment, she has a testing environment and a production environment. And this is according, again, I said, best practices for that separation of concern. If something happened like a data breach, you can limit the impact in one of these environments and it doesn't replicate across the different environments. So the challenges that she's facing, I mentioned the cluster management, how she enforce best practices and deploy these clusters with these best practices, add-on management, team management as well for more than one cluster. How can she manage the teams for different clusters? And workload management, how can she provision the workloads in these clusters? So what her environment is what's on the left of the image. So again, all these ropes, it's a tangled mess, and she needs to figure out how she's going to streamline this and tie everything together to look like the rope on the right. And this is a challenge. These are challenges that a lot of platform teams face, DevOps teams, when they have configuration across dozens of clusters. This is very common. And without automation, managing them can become very cumbersome. So Obviously, the solution for that is the topic of my talk. You can do this, manage everything using Amazon EKS blueprints. So this blueprints is an open source framework that enables administrators to deploy in a standardized and repeatable, reusable way, robust EKS clusters. So they include best practices and configurations that helps set up production-ready environment with all the integrated tooling. So those day two challenges, add-ons that she needed to install, they come already with these EKS blueprints. And they all consist of infrastructure as code templates. So just few lines of code that you can do in your terminal, and they'll define the architecture of your EKS cluster. So having everything from the compute, security, networking, everything that you need, all from these templates. Now, like I mentioned, these EKS blueprints, they have two flavors. You can use either the AWS CDK, so the Cloud Development Kit for that, the constructs of the CDK, or you can choose to manage them with Terraform modules. They are both very easy. I'll show you a demo in a little bit of how to use them with Terraform modules, but it depends on how you feel more comfortable with. And now let's go over how these blueprints, they help us build a production-ready EKS environment. So like I mentioned, you have the compute. So at first, it helps us allow, it creates all the cluster and everything that comes with it. So the VPC, security groups, everything will be taken care of for us. And it gives us the flexibility to proper configure it. So we can choose to run it on Amazon EKS or also Bottle Rocket. We can choose the operating system if we want Amazon Linux, or if even we can use AWS Fargate for that. And we can also mix and match those as well. On top of that, I mentioned the add-ons that you can install. There are several of them, and they are all in the documentation. And there are three different types of add-ons that you can install. So the first of them is the official AWS components, like that you see also on the console that you can install from the console. But add-ons like Core DNS and the Amazon EBS CSI driver. Then there are the open source tools that I mentioned from the CNCF landscape, and also from outside of the CNCF ecosystem, but open source solutions like Cluster Autoscaler to optimize the resource allocation if you're leveraging managed node groups with your EKS environment, and also Argo CD, for instance, for GitOps. And also the add-ons can be partner created add-ons. So for instance, the Vimcast for Kubernetes. So if your company wants to create an add-on for the EKS blueprint, you can also do so. It's very easy. And again, like I said, it's all open source, available for you. All the code base is on GitHub. It's very easy to do so. Now, I said the add-ons and the EKS blueprints are based on best practices, and but installing them is just a few lines of code. You just enable them to true, set them to true. And for instance, here in this screenshot, we're installing the metric server and kubecast on our cluster. And if you need more than this default setting, the blueprints and the add-ons are very customizable as well. So if you have different requirements than what the template gives you, you can also customize them to your needs and fine-tune the configurations if you need to optimize your deployment and whatever you need to do. There is this GitHub with the Terraform EKS blueprint add-ons, but also I'll also share more resources towards the end of the talk. Now, like I said, not only it helps with, installing and deploying the compute, installing the add-ons, you can also help, these blueprints also help managing different teams. So you can create these teams like a development team, a platform team, and manage the access and permissions by using infrastructure as code. And this helps with separation of concern. So your platform team can just manage the clusters, and the application team, the software developers, can just focus on building their application on top of these of the infrastructure, the cluster, the EKS cluster. So just a summary, what you get with these EKS blueprints, I've talked a lot about this, but you get the cluster management. So you deploy the EKS clusters with all the compute capacity. You can replicate them with infrastructure as code. You also get add-on management. So the full lifecycle management of these add-ons, from installing them, upgrading them, retiring them, and it makes the onboarding of those day two challenges, the components, faster and repeatable. Also, it helps with team management and with application delivery. So you can integrate the GitOps tooling to be able to manage your workloads across different clusters. And again, infrastructure as code, I'm sure you're familiar with it. It gives you a document so you can audit that and outline all the configurations of your environment. So from the add-ons, the teams, the applications running on it, you can just generate a document or a template, and you can replicate that across different environments. You can share that with others. And that's the beauty of infrastructure as code. Now, the documentation. So I encourage you to check the EKS blueprints documentation. There are two different ones, one for CDK and one for Terraform. You'll find all the add-ons there, and there are, step-by-step guides on how to get started, how you can test them in a development environment, which is, again, best practice to do so before you implement these blueprints in your production environment. The open source repositories, they are frequently updated with new resources. So it's great to be checking on them frequently. You can also help out with these open source initiatives from AWS, and you can contribute to them, not only creating add-ons, but again, if you want to help with documentation, whatever it is, you can also do so with these open source repositories. And besides these blueprints, there is what's called EKS blueprints patterns, which are built on top of the blueprints by providing a more specific use case for your environment. So I would say it's a more opinionated setup to quickly address specific needs, making it easier to deploy workloads on top of the EKS clusters. So for instance, if you need a pattern for CI/CD pipelines or data processing frameworks, they have different examples for that, and you can just use those, and they are also customizable. They come with best practices, but if you need to modify to suit your project requirement, you can also do that with these patterns. So if you're interested, if you're curious about using these EKS blueprints, I encourage you to take a look at the documentation. But at first, I would tell you, begin assessing your infrastructure needs so you can effectively plan the EKS cluster setup and also test them in a testing environment first before deploying everything on a production environment. Now, let's go through a quick demo. It's not live. I recorded this because 4 out of 5 times I've had problems with live demos. So I know Darko just did that, but it's not a best practice. Now, this demo is just a simple example on how to use EKS blueprints with Terraform, so Terraform modules, to create an EKS cluster and install an add-on. So let me show you here. Let's start. I have this Terraform template that here, let me click play. Yeah. So I already deployed this template because sometimes it takes a while. And there are some variables like the region that is going to be deployed, the Kubernetes certificate, the cluster certificate that the cluster is going to be using, and some Helm configuration there as well. Then if we scroll down, we're going to see the cluster section over there. And we have the official EKS Terraform module. So setting the module version. Also, we have the Kubernetes cluster version 1.27. We're creating a new VPC that I'm going to show you down below the file. And we're setting a managed node group of M5 large with a minimum size of 1, a maximum size of 5 instances, and a desired size of 2. And down below, I'm enabling the add-ons. So like I told you, there are the official AWS add-ons. So I'm enabling AWS EBS CSI, Core DNS, the VPC CNI, and the Kube proxy. And I'm going to add 2 more from the open source groups, which are the metric server and the certificate manager. And again, you see, it's just setting them to true. Then I'm creating 2 different teams. If you can see EKS blueprint on that part, blueprint team, I'm creating an admin team, which has the enable admin setting flag to true, which means these users, they have ability to do anything on the cluster, to create, to read everything. And I'm also creating a dev team, which only has the ability to view resources within their namespace. So they don't have any write or read permission. Again, I'm adding some labels, like for each red label, this is just everything is part of the template. You can just copy and paste. Everything is part of the default configuration. And then after that, I'm creating resource quotas for my namespaces, which is a best practice for Kubernetes. I'm also setting the limit range for the pod, for the PVC, and for the container itself. And down below is the supporting resources. So where I'm creating the VPC module and the security groups and everything that I need for networking. Now you can see on the console, I have already created the cluster. And you can see on my compute part that I have the 2 nodes, the 2 M5 large nodes. And I can see that on the terminal as well. If I do kubectl get nodes, I can see those 2 nodes are running. And if I do kubectl get pods -a, I can see all the pods and the add-ons that I've installed. And everything was, once I did Terraform apply, everything was installed for me. Now I want to go through the scenario of creating a simple application and Nginx deployment with 3 pods on my nodes. And I'm going to create them using an ingress, using the load balancer controller. So for that, I'm going back to my main file on Terraform, and I'm going to uncomment that add-on to true. I'm going to save that, and I'm going to run Terraform again to apply that configuration. And you're going to see it's very easy. It's going to run that for me, and I create that balancer controller for me. So let's wait a few seconds. And then yeah, it's running. Then we're going to check the pods once this is done. Yeah, now we're going to check the pods deployed in the cluster, and we'll see that the load balancer controller was installed there. So if you see there, yeah, the load balancer controller is there. Now, next, I'm going to show you, I have already created this simple deployment that will be deployed on Team Blue only. So right now I'm an admin, and I have the capability of deploying anything. And this is an Nginx image on port 80. And I'm creating also a service on cluster IP. And also I'm finally creating an ingress using that AWS load balancer controller. So for internet-facing load balancer, so we have the public address redirecting into my service on /. What we're going to do now is kubectl apply. So let's go to the terminal and do kubectl apply -f and the name of the file. And behind the scenes is going to create everything for me, all those resources on the Team Blue namespace. And then if I get all the resources from the namespace, I'm going to see the pods that were created, the service again. And I also can see, if I check the ingress, I can see we've created the load balancer for us. So we can see the DNS record there. And now I'm just going to show you, I'm going to change the role in the kubectl config file. So I'm going to copy the command there that I have. And from admin, right now I'm an admin and I can do everything. And I'm going to change to be a developer. So I'm going to be on Team Blue, a Team Blue user. And I can check that on the config file. And what is the difference from that? You'll see that, let's just check the config file. You can see there we're Team Blue. And what is the difference? You can see if we try to see the resources from all the namespace, we'll get an error because we don't have the permissions. So we've set those permissions on the main file. And if we try to see just the pods from the Team Blue namespace, we'll be able to do so because that's what we have permissions for. And we can also see the ingress controller that we deployed from that Team Blue. And so let's check this, the controller, change from get pods to get ingress. And if we copy we'll get the DNS address again. If we copy it and we paste it on the HTTP port, we can see the Nginx app running, which behind the scenes is redirecting into my EKS cluster. So it was, a very quick demo, so you can see the capabilities of the EKS blueprint. And there is a lot more, is customizable, but again, it's a simple way to deploy those clusters in a repeatable way using infrastructure as code. I think my time is up, but if you have any questions, I might be able to take some questions. Actually, no, 10:30. But yeah, after I'll be outside and I'm happy to talk more about this. Thank you so much for watching it. Now to Bill Tarr will talk about SaaS, right? Awesome, thank you for that.